Started my first startup in '97. The world told me I was insane.
Our goal is creating future economies that are more regenerative and sustainable.
Something didn't match up. Why hasn't this become the next big thing? And that's where we invested.
The whole purpose of achieving anything in life is measurement.
It's my pleasure to kick off this panel. Thank you for spending time and taking time out of your busy days to join us at Shadow Summit 2021. Just so everyone knows, this is the Bringing Digital Twin Technology and AI to the Civil Infrastructure Asset Management Community session. It's a mouthful. We're actually, so we were just catching up on some of the infrastructure bill session notes. I think there's some pretty interesting discussions there. I mean, literally the infrastructure bill in large part was created to fund fund redevelopment of bridges, roads, just critical infrastructure across the US. And so like the part that I was really interested in with this panel in particular was we hope to also gain, not just rebuild some of the critical infrastructure, but gain a lot of advantages and leverage through technology while we're kind of moving through that process. So the funding is one part, but the technology is another part. And Edgar and Ali, they are founders of Aren, which is an AI company for civil infrastructure. They're a portfolio company of Shadow Ventures, full disclosure. So please shamelessly plug yourselves, the entire panel. But we're super excited to have everyone here. It's a very esteemed panel. It's been a great day of discussion. So Edgar and Ali, I'll pass it to you and let you introduce your panelists.
Thank you, Nick. Really appreciate it. Ali, do you wanna jump in?
Yeah, with pleasure. Thank you so much, Nick, for the intro for this session. Hello, everybody, and thank you so much for joining this panel about digital twin, artificial intelligence, and applying that to civil infrastructure systems. So with a way of introduction, I am Ali Khaloo, CEO of Aren, and then I'm going to be one of the moderators of this session. So just a little bit of background. Aren is a VC-backed company, which is based in New York City. And what we do is we are building a business-to-business software as a service civil infrastructure management platform to help both the asset owners and engineering firms to assess and manage infrastructure using a combination of civil engineering, machine learning, and computer vision. So with that, I would pass it on to Edgar to introduce themselves, and then we're going to go around and introduce our esteemed panelists.
Sure. So I'll keep it brief. I'm Edgar. I'm the CEO of Aren. And more important than Aren, it's the great, super smart, super well-informed, very experienced panel that we have, and we're really excited to be able to share with you guys, the audience, the perspective of civil infrastructure asset management in North America and also in Europe. So with that, I'll let each of us introduce ourselves, and I'll let maybe Dennis start from Antea.
Thank you, Ali, Edgar. Thank you for the invitation. I'm Dennis Jansen. I'm head of the advisor group asset management from Antea. We are a worldwide operating engineering company. My main base is in the Netherlands. Maybe you all know, but as you should know about the Netherlands, we have a lot of water, so we have a lot of bridges. And with my team of professionals, we advise the local government, the railway government, on trying to get the most out of the critical infrastructure. And with the collaboration with Ali and Edgar, we put in the excellent technique to advise the railway government on enhancing then maintenance to a predictive site. So I'm looking forward to this discussion and make an excuse on beforehand for my for Netherlands' sake, okay English, but I hope you can follow me and help me through get through it if I need some help. Thanks. Should I pass it on to anybody?
Mike, do you wanna? Thank you, Dennis.
Sure.
And by the way, your English is great, Dennis. Don't worry.
Yeah, I was just going to make the very same comment. Again, I can't speak a second language nearly as well as your English is, so I credit to you in that. But I'm Mike Giacco, Director of Technology at AI Engineers, based out of Connecticut. Full disclosure, the A and I have nothing to do with artificial intelligence. It's actually the initials of our president and CEO. But coincidentally, we've been able to leverage those initials through Edgar and Ali's platform. Quickly, AI Engineers is a civil infrastructure firm. Everything from bridges, highways, roadways, facilities, civil survey, you name it. We're everything with the exception of environmental and geotechnical engineering. We have a very robust technology program, which really sets us apart from a lot of our competition. That includes drones, terrestrial laser scanning, wireless sensory technology, AR, VR, you name it. We don't just talk about it and try to play in the sandbox. We like to be at the forefront of it and really introduce our clients to all the benefits that technology brings. And of course, here we're going to be talking about artificial intelligence. And you'll hear my comment probably throughout this presentation that a lot of companies are talking the talk, but none are walking the walk. And Ali and Edgar have allowed our companies to actually do that. So I'll pass it over to Damian, who has some hands-on experience like I do with Aren's platform.
Thanks, Mike. Appreciate you introducing AI, so I don't have to. That was perfect. Very briefly about myself, I oversee our evaluation group, so load rating, instrumentation, and then I assist as well company-wide on bridge inspection processes. So, kind of the bread and butter of what our company does and where we see this technology really helping quite a bit. Charles?
Hey, how you doing, guys? Thank you again, Mike, for the introduction for the company. Just like Damian said, I have to do all that spiel. But my background is electrical engineer, and part of AI Engineers, we have a facilities group which deal with buildings. And where I got into this is with the LiDAR scanning with the bridges, roads, and other civil infrastructure, which was eye-opening from my part and from my point of view. The LiDAR technology is what got a foot in the door, and it seems to be helping and complementing what Aren is doing, which is awesome to see, because we used it from just a documentation standpoint and maybe not do an extra site investigation or something. So to see it, the potential of it, where it can actually go, is really, really eye-opening, and it has my full attention. Thank you, guys.
Thank you, Charles. So what we thought, we'll the interesting conversation is really going to come from our panelists, and what we wanted to give, just to put a little bit of what do we mean by AI, artificial intelligence, and digital twins. We want to share a little bit of the work that we have done, because I think that gives a good background, right? So I'm going to share my screen. And actually, Nick, do you know I'm not being able to share the screen? Do you know if
I think
you
it's
guys...
locked. It's the same issue with me.
Yeah?
I'm seeing the same thing too. It seems to be locked for some reason.
Let me try something quick. Well, I'll get a hold of Nick. But while we do that, maybe then let's get started. And I think something I wanna follow on a little bit the comment that Nick did regarding the previous conversation, right, on infrastructure bill. And I think, at the end, as Nick said, the title, it's a mouthful. But really what we're trying to explore in this conversation is, where do we think the future is in terms of bringing technology into civil infrastructure asset management, right? And then where do we think we are? And what do we think are the steps that we should be taking towards bridging that gap, right? And with that being said, I'll start with a question, and really let's see where this conversation evolves. And it's for all of you, Dennis, Mike, Damian, and Charles, is how are you incorporating today technology into operations, right? And how do you envision the use of technology to improve those operations, right? If you can give us your point of view on that, right? And it can be as well like where you are not doing it and where you think you should.
Dennis, why don't you lead, and we'll just go around the table like how we introduced ourselves.
Okay, no problem at all. I think it's a combination between the technique and the knowledge of our engineers. If you put the technique and it's developing really fast. If you put the technique and you add the experience of an engineer and the global thinking or the local thinking of the engineer, you have the right combination. If you only depend on the machine or a photo or information, I think that's not a good idea. You always search for the combination to maintain those infrastructure on a high level. And in the Netherlands, we want to have it on the highest level because we are an expert country. So the infrastructure needs to be tip top. You can't let it down on the sea level. We are working with levels A through to D. A is top level, and D is the lowest level. We can't afford to have our infrastructure on the D level. We have to have it A level. So you don't fully recommend and depend on a machine or a technique. No, you put some really expert of an engineer into it, and together you have to go. In my opinion, you have to go the combination. So it's a combination between man and machine.
I very much agree with you, Dennis. Technology has played a very big role here at AI Engineers. Fortunately, our president and CEO, who is the A and the I in the company name, basically mandated that we adopt technology. For lack of a better term, Abul Islam, who is the A and the I, is a visionary in the sense that he understood almost 10 years ago where technology was going to be seriously taken within our actual engineer practices. I think a lot of the stuff you see sometimes becomes very flowery, almost unbelievable, something you pretty much expect to see maybe on Discovery Channel or something like that with some wannabe engineer trying to convince you that it's cutting edge and all this and that. Truth of the matter, a lot of the stuff we do has to be practical, but most importantly, it's got to be acceptable to our clients. We found the majority of our success with our drone program early on, about 7 years ago, where we finally convinced a lot of our local departments of transportation to understand how leveraging that technology could lead to some great advantages. Fast forward up to about 2 years ago when out of the blue and frankly making some of my dreams come true, Ali contacted me and we had this idea that we were going to take a lot of the data collection we had that was, for lack of a better term, face value, everything you see on the exterior, but it needed an engineer component. We were going to collect photos with a drone. An engineer or qualified bridge inspector would have to spend hours analyzing those photos, chasing cracks, finding deficiencies, almost making it counterproductive in a sense. The technology almost exacerbated the inspection process to a degree because certain things through the National Bridge Inspection Program only require a level or a certain amount of steps to the traditional inspection process, which allowed for time-efficient inspections, scheduling and budget control, things like that. But then when we go ahead and we collect this plethora of data, someone's got to digest it. And it almost led to kind of a backwards result where the abundance of data would lead to more time and to more money spent. Well, in comes Aren, and Aren not only takes the data that we've collected and analyzes it, but now we can visualize and see all those results almost instantaneously. that has been a real game changer for us. One of our mantras is we don't adopt a technology unless it can help us do a task better, faster, and cheaper. We do not do technology just for technology's sake. And Aren is a really shining example of that. I mentioned earlier, in my introduction, other companies are presenting, talking about artificial intelligence, basically framing that they've adopted something along these lines. And when it comes down to it, a real deliverable, something that could be billable to a client, the results just aren't there. Well, we've been very fortunate that with Aren to date, we've done a couple actual billable projects where the results have gone on record as actual documented and accepted inspection reporting. And clients are now seeking out this particular product because they know it's not just all smoke and mirrors. It's creating some real hard engineering results that are allowing our inspectors and everyone here at our firm to do their job better and faster. So we really see it in the near future becoming an integral part of analyzing the data that we do collect frequently. And it's only going to continue to grow as the algorithm begins to be refined. We diversify our subjects that we're analyzing that much further. We really see the possibilities being almost endless with this technology. Damian, do you have anything?
Yeah, I want to, at the risk of being too broad of a stroke, in general, as someone who's stuck with client deadlines and bridge owners specifically, but the same would apply to any asset owner, buildings, anything in the built environment. We want to apply the concept of technology anywhere where we feel like there's an efficiency to be made. Something that we're doing that's redundant or repetitive or time consuming or thoughtless in some situations or some aspects of asset ownership. And this is a technology that allows for that efficiency. When we're talking about segmental concrete box structures or reinforced concrete structures, and we have hundreds and thousands and tens of thousands of square feet of area to assess, and someone literally drawing with a crayon, because that's what the NBIS, the National Bridge Inspection Standards that we are adhered to, that when someone's drawing with a crayon on the structure and trying to figure out how long a crack is, and then manually converting that to an AutoCAD drawing, and then making that sketch and updating that sketch every 2 years on structures that are so large and full of hairline cracks, especially as our infrastructure ages, that is an area that's really ripe for kind of improvement. And this is a very adaptable analogy that I feel applies to bridges, roads, buildings, again, anything built, and anything that we feel is sort of that repetitive, redundant, time-consuming, but it's labor. Anywhere where we can improve that's where we really want to use the technology in general. And this is a technology that really fits that bill for us.
Charles, any comments from you?
Yes. What I can definitely speak to is the inspection portion. My little exposure to the inspection portion, like what Damian was speaking about. The fact that your technology can pinpoint those spalling areas and the fractures autonomously makes it just so much more effective as far as time management goes. And the repetitive tasks, let's just be honest about it, some of the boring stuff, you could definitely have just AI, artificial intelligence, take care of the boring stuff, and you could take care of the more quality assurance client relationships, so that your time is not being minimized per se, but you're focusing your time more on dealing with personnel, training of staff, client relationships, which is literally the backbone of any business, but definitely in the business that we're in. So that's how I'm seeing utilizing technology. Take care of repetitive, boring stuff that no one really wants to do, but at the same time, getting the same quality, getting the same deliverables to the clients. Without knowing that you can focus more on developing your people and your company.
And then following up on that, right? I think we have the privilege to count with partners, right? That are very forward-looking, right? Now, I think we all know this is a big market. And this is a market that overall, right, it's it needs to adopt technology as a whole, right? My question to you, Dennis, Mike, Damian, and Charles is, what do you think are going to be the key catalysts, right, to really increase the penetration of technology into the space of civil infrastructure, right? Because I think it's very different. You know, we keep engaging with partners like you, right? And there's more and more and more, but still, you know, there's the whole market, right? That, what do you think will be those critical things that we'll need to hit, right? You know, like even Nick mentioned before, right? Like they were talking about infrastructure bill. Is it like at a government level? Is it like the companies themselves, the asset owners? What are your points of view?
You want to start off with me, or?
Yeah, let's go, Dennis.
Okay, no problem at all.
Let's go, Dennis.
We have like, in comparison, we have like a little infrastructure, but it's worth over 300 billion, and it's built in the 60s, 70s, 80s. So we have to replace a lot of critical infrastructures. For example, we have like the port of Rotterdam. That's where all the goods are delivered and transported into the eastern of Europe. That's the main gate of Europe, the port of Rotterdam. And there are bridges that need to be rebuilt. So taking out the bridge for like a half a year, 2 years, 3 years would be a serious problem, because if you don't do it on a good part, you have a really big economical problem, and I think that's the main catalysator to start doing things and putting this file on top of mind on the ministry, because and I saw the live introduction just an hour ago. First of all, you need money. So we need like 50 billion for the next 10 years to invest and rebuild some critical infrastructures on the western part. So I think funding and to get the investment is the main criteria, and would be the biggest catalysator in this side. On the other hand, technology to with sensoring and monitoring critical infrastructure to get the most out of it on the life cycle costs, to keep them very low, and to make the good decisions on rebuilding and timing the rebuilding. That's the biggest part. And this technology, even almost every technology is a big investment and a catalysator on the greatest file. I think it's the biggest file we in the Netherlands have. It's our destination. We live on export, so it's critical to the nation. So I think for us the biggest problem is to get the investment, and this technology speeds up and makes you make the best decision in maintaining the critical infrastructure. So that's on our side. I'm curious if you see some comparisons or not, Michael.
Very much so, Dennis. And I think really what we've seen is a lot of introducing technology or utilizing technology in the civil infrastructure world comes down to client understanding, adaption, and acceptance. And what I mean by that is, we go ahead and we introduce a technology like Aren, and we say, hey, we're going to show up on your job site and use artificial intelligence. Well, first we get scoffed at, because again, it's such a flowery idea, at least at this point in time. We're doing real billable work. This is serious stuff. We can't fool around, and time is of the essence, especially to your point, Dennis. Budgets are very tight. This infrastructure bill, as much as we know it's been signed off on, is going to be parsed and parted off to very different, in strategic places that might not reach some of the areas that we're hoping that it can. So we need to be smart about and understanding of how this technology really realistically can be utilized to improve our processes. Secondly, I think it needs to be really adaptable. And that's something that Aren's technology is. We need to be able to have thresholds for most basic of terms, whether it's crack widths or spall sizes, things like that, that any particular client wants to have customized to that asset or level of reporting for themselves. It also needs to be utilitarian in the sense that we just don't want to look at bridges. We want to look at concrete facades of buildings. We want to look at retaining walls. We want to look at ancillary structures. And if we have that level of adaptability, a client's not going to feel very handcuffed for one technology fitting one particular purpose. And finally, I think probably the biggest aspect of this all is acceptance. Damian and I both mentioned NBIS. No client is going to say, hey guys, we can let that go. We like what you did and we'll put it on record. Never will happen. We'll never get federal funding for their programs ever again if it's that lenient. So we need to make sure that we can produce a product that has such a level of validity and quality and ascertain a level of assurance as well too, that the client is willing to put that on record right next to the previous accepted inspection reports for the previous cycles. Without that acceptance, we don't get to do any of this. Sure, we could take it on our chin and have a nice example as a proof of concept to a client and say, hey, in the future, we hope you take advantage of this. But is that really helping? Sure, to a degree, but not really. So if we get a client, which we have fortunately have the opportunity to accept the findings, put it on record and say, hey, future inspections can be done with the very same methods, that's a win for us. And that's really where we see technology being introduced and really being a prevalent part of our real work. Damian, do you have anything?
No, I think you hit the nail on the head there with repeatability, and then just the ability to go back in on 6 month, 12 month, 24-month intervals and do the exact same process with a completely different group of people, right? Different equipment, different staff, but they're going to end up with a product that's the same. Like that's never been the case before. Even if you go back 5, 6, 7 years ago, when people first started saying, hey, we're going to inspect a bridge with a drone, and obviously NBIS isn't going to allow it yet because it's not hands-on. Fast forward now, there's been NCHRP studies and TRB studies, and it's moving towards FHWA acceptance. Once the feds accept it, it then becomes, a viable entity. And this is a far more repeatable and far more standardized, if that makes sense. To get the same inspection, with a drone year after year, you have to fly the same pattern. And you can save that data. You can fly the drone in the same exact pattern and have that GPS data. The beauty of this is that it's repeatable with any staff on any equipment, and it doesn't require that very hard set of, you have to stand in this location and take this many pictures facing this direction at this angle. That's gone now. As long as anybody's blanketing a structure, they're going to have that same level of detail and repeatability. And so that, to me, once you have funding, you then need to have a product that's viable. So the money, like Dennis mentioned, is huge, but also acceptance by the feds, and that's what these studies do. That's what these proof of concepts are for. And then finally, when the FHWA or whatever entity in the European Union has, that's what allows this to move forward very, very quickly, because everybody already knows it saves money and time, and every bridge owner, every building owner wants to save money.
Anything, Charles?
Yeah, just had to take a little step back to really think about anytime we're in it, in general speaking, when you're pioneering something, you have to be almost perfect, right? Because as soon as you mess up on something, then they start blaming the technology. So I always go back to, let's make sure that people understand, the people who are operating these platform new software, whether we're collaborating like Aren and AI engineers are collaborating, are we trusting each other? And are we going to make sure we follow through on everything that we're doing? So I have to say, this is a prime example of something that works. We both trust each other, that we are dedicated to this. Our technology does work the way it's supposed to. And when we put it together, sometimes we find that it works a little better than we thought, and we have to make sure that we have to highlight those items also, because it really comes down to when you're a pioneer. Oh man, you have to be almost perfect. Think about 10 years ago with the drone flights and everything else, and even Mike, when you started drone flights, I mean, I remember being with you, and we went through routes, 5, 6, 7 times to make sure we had it perfect because it had to be perfect, And I think that's part of the acceptance where a client will come and see us now. We are not rookies. We are not new to this. We are the experts in this field, and we are acting accordingly. And that's part of the acceptance from the client part. And that's just my take on this, to make sure that people understand it and make sure we can penetrate new markets, is being the expert in it on every single level.
Edgar, you're on mute.
Can you hear me? Yeah.
Yes.
I have a follow-up on this, but before that, I think we found a way to share what we meant, right? So let me, just at a high level, right? Like when we're talking about these technologies, and there's many technologies out there, right? And I think the trick is that a lot of people mean different things when you talk about artificial intelligence and when you talk about things like digital twins or even asset management, right? So to put a little bit of color to that, what we are doing with Dennis, with Mike and team, really it's aggregating all the data that they're collecting, right? With things like, in the simplest case, cameras, which can be varied cameras, right, including drones and laser scanners, right, and videos, and then creating a 3D high resolution model of these assets in a way that then enables us to do the damage assessment, right, using artificial intelligence to provide, to identify, quantify damage, characterize it, and understand how it's evolving through time, right? So with that being said, let me share. I hope this works. I'm going to share. Hopefully you can see. This is, and I'm going to try to be brief,
Yep,
right?
I can see.
Ali, you want to go ahead with this one?
Yeah, absolutely. So what you're all seeing is one of the projects that we did in Europe. And just again, to put things in perspective, as Edgar mentioned, aggregating data and analyzing them. What happened in here is we received more than 2,000 photos from the client on this concrete bridge that you're seeing here. And what we did after that is we took all of that information, and that was coming from drones, handheld cameras, iPhones, like you name it, in terms of the visual data. We took that information and we created that 3D model that you saw, just to put everything in a contextualized environment that now you can see have this digital replica of the asset. We are applying our artificial intelligence to detect different damages. So what you're seeing now is that labeled 3D digital replica or digital twin. And for example, any of those distinctive colors, from red showing the fluorescence to that mint green color is showing the spalling, or the purple color showing cracks. What we are actually able to do is running those kind of analysis to, back to the point that Damian and Charles was mentioning, some of that repetitive work that by its nature, it's very much subjective. Like I can go out and do an inspection and find maybe 10 cracks, and maybe Damian goes out and find 12 cracks. Like we want to make it consistent. And that's what we're doing by using new technology, move towards a more consistent assessment and an objective assessment, that now whenever you go back again out there, do the data collection again, and that can be a new firm even, by running the analysis, do the comparison, you can keep track of all the changes that happens on your asset. And now it starts to, with all of that information, now you can start to make better decisions when it comes down to the asset management aspect of things. How much money you should spend, or do I need to fix something or not? All of that.
So, that was just a little pause, and sorry for you'll excuse the firemen outside. I'm in New York, and we're in New York, so it gets a little bit noisy, but that's part of the charm, I guess. So, after the transition, like we just want to give that, just to a little bit put in perspective what we're talking about in terms of technology, right? But picking up on where we were discussing about how do you increase the penetration, right? I think you all mentioned the asset owners, and very specifically, I think government, right? What are your points of view? And feel free to skip if most of the work it's in public. But how do you think that changes, for example, when you're talking about assets where there could be a large component of private sector, right? And if I understand well, dams, for example, 50% of them, at least in the US, I don't know in Europe, Dennis, but at least in the US, are privately owned, right? Or, things like what you were mentioning, Michael, building facades. How do you see that? Do you think it's a similar dynamic in order to increase the penetration, or do you think that it's different because the asset owner it's private? Dennis, what are your thoughts, Dennis?
Yeah, I think if private property, I would think makes it a little bit easier, because I think the Netherlands, the governments are really traditional, so they stick to the plan they already are doing for 10, 15, or stick to the technique they are already doing for 10, 15 years. It's proven. It's helped them getting at the point where they are right now. So that's going to be a long one. You have to take that would be long term. So it needs to be proven. It needs to be certified. I just heard. I think Michael said something about the federal government on giving an acceptation or a green light for the technique. So that's the same situation over here. And I think if you're getting to the private properties or buildings or something like that, I think it would be easier, because people make better decisions when they're responsible for it and they own something. So I think they're more open to new techniques that suits them well and help them save or spend a little bit less money, and to get the same revenues out of the asset. So I think private makes it a little bit easier. Would be my expectation.
I would agree with Dennis as well too. We see obviously some of the very same hurdles over here. Whether it's our government being traditional or whether it's just taking a lot of time to enact any amount of change with a lot of the federal guidelines and things that really play into how our federal dollars are divvied on up. When it comes to privatized entities, obviously they have their own money, they have their own policy, they have their own level of inspection and what needs to be reported and go on record. Now, with that all being said, just because they're privatized and they can do what they want doesn't mean that they will. And a lot of the implementation of this new technology rests on our shoulders. We need to show these clients what is out there right now, what is truly viable, and educate them to a point where they're comfortable with implementing that technology. Ali, Edgar, and I had a nuclear power provider that we were so close to actually pulling the trigger on, and it had nothing to do with their technology. It had everything to do with, frankly, drone technology, and more specifically, federally accepted drone platforms to be allowed on certain properties. And that's really what the pitfall was. We had the client totally understanding what Aren's technology was going to do. They were frankly blown away by the fact that we could analyze one of their structures in what would traditionally take weeks and basically a morning. And they didn't just buy in, they became an advocate of it, to the point where we had multiple conversations on how we could try to, for lack of a better term, cut corners, take some chances with some drone platforms, see what might be halfway acceptable, and then, ask for forgiveness, then for permission after the fact. And we said, guys, that's just not the professional way to do this. Even if it's you, the owner, telling us to do so, we can't just do that. So with all that being said, at the end of the day, it comes down and it rests a lot on our shoulders as that service provider to educate our clients and prospective end users on what the technology can do. And most importantly, that it's viable. It's not just producing false results or creating some pretty picture. I think one term that I've really started to utilize in a lot of my discussions that Ali, kind of ingrained in me is contextualize. And I think that's really what their software is head and shoulders above any other software. Analyzing a structure in 3 dimensions rather than just what everyone's talking about right now, taking a 2D picture, running it through some algorithm, having that one picture yield some results, giving you a report that frankly just exacerbates the process, because now not only do you have a single photo that you have to analyze, but you got to analyze the results. You got to look for false positives. You got to find a way to make sure it's easily digestible to your client. Frankly, it makes the process harder. When you get into the 3rd dimension and you can play that video like you just showed, Edgar, to your client, it clicks. It's so easy to understand, and it allows you to feel comfortable with the results. Again, you're not just looking at a snapshot of a particular area of the bridge. And when you're talking about large signature structures on major civil infrastructure like interstate highways, these bridges are expansive, but they're also very redundant in their construction. So to take a look at one photo and try to identify that across a gigantic signature structure bridge, not only is tough to actually understand, but it's also tough to swallow as an end user, or excuse me, as an asset owner, to believe that result is true and valid. Now we show you the entire structure. We can zoom on into that particular area. And the understanding and context that provides really makes that pill easy to swallow for our clients, and has been probably the biggest reason why we've gained that acceptance. We've taken the time, and again, credit to Edgar and Ali. They've spent a lot of their time showing up to our meetings with our clients to substantiate their technology, thoroughly explain it so everyone's comfortable with it, and eventually enact it and yield the positive results that we have seen. I'm going to pass it to Charles now. I just want to make mention, Damian unfortunately had one of those meetings with our clients right now. So he had to appear and go over to that. But Charles, any thoughts to what I just mentioned?
Yes, I do want to echo what you said, Mike, with Ali and Edgar. Context. Like I said, my background is electrical engineering, particularly in buildings, but we also obviously do infrastructure, bridges and other assets. And seeing the technology in use in the results of it, of something that a structure that I was a part of and I was participating in, and then seeing the end result of it, it felt literally like a digital twin, like a digital twin, like the headline states. And it was that way in every way possible. But it also gave context to, okay, this is a fracture, these are Spauldings, and I'm telling you, it's pictures with 1,000 words. It's pictures, it's 3D. You understand what you're looking at, you understand where you're looking, and you understand, if it's a chart or a graph, you can go to that information also, or you can just look at the asset, digital twin asset in and of itself, which I can really attest to from someone who's not natively from that background. It was easy to find out where I was and what I was looking at. And if I can figure that out, I figured, okay, show this to a client, they will get it, almost instantaneously. And I think that is one of the biggest selling points. You don't have to reinterpret what you're looking at. It's a bridge, it's a structure, it's a column. You see it in 3D. It's not a 2D platform. It's a 3D platform. We see our road in 3D. It's very, very easy to associate yourself. It's very easy to see the context of it. And I think the work we do on the back end is what really helps us show that up front so seamlessly and so easily to clients and to even ourselves. I think of ourselves as clients sometimes. We're showing to other departments so that they can understand exactly what we're doing and exactly what we're trying to achieve with this technology. So thank you again, Ali and Edgar.
Thank you. So I think
Absolutely.
we got lucky, and the share screen now it's working. So I'm going to share, and I'm going to let Ali walk us through 2 projects. We'll walk through them really quick, and then we'll get to like talk about them with both. One is a project that we did with Dennis. Another one, it's a project we did with Mike. As I share screen, I just wanted to leave a thought on your minds in case we have time later to continue this thread, and that is, you mentioned, yes, the when it's public, it's really hard, right? I think something that it's always of a lot of interest to me, it's, we know that there's a huge gap in the investment that we have to do, right? I think Dennis mentioned 50 billion in the Netherlands. The numbers that we've seen, it's like 15 trillion at a global level, right? In the next 25 years, it's just brutal, right? But then when you look at another aspect, which is, there's a lot of research around how efficient it's the spending, right? And there are numbers there. I think there's a few numbers out there from McKinsey that talk about like 40% of the spend being very suboptimal, right? So it's, this is at a macro level, right? So it's not an easy thing to bring it to a quick solution and finding. It's a really hard problem to solve, right? And it's like kind of like the chicken and the egg, right? Well, we have the suboptimal spending. We need more money. There has to be a way to like address both. The problem is it's a chicken and egg to convince the public asset owners, right? But just I'll leave that as in case we have time. I'm gonna share my screen to walk through the 2 projects. Give me a second. Can you see my screen?
Yes.
Yes.
Right. So in the interest of time, Ali, let's walk through both of them quickly so that we have time for Dennis and Mike and Charles to actually talk about them. So I'll let you go, Ali.
Absolutely. So just to put the project in perspective, or what is the project we're talking about? The first one is a project that we did with Mike and his team at AI Engineers. And this was a bridge which was in northeast of the US. In this case, we were focused on underneath of a bridge deck. And underneath of that bridge, we had very important equipment. And the bridge, just to put it mildly, was not in the best shape. You're seeing some of the photos here. And what has happened was, so it was very important for the asset owner to not only capture what's the current condition of that asset, but also they wanted to see how it's evolving through time, like going from poor condition maybe to almost failure or critical condition. They really wanted to see how things are progressing through time. And they wanted to do it at the higher frequency as the usual inspection or biannual inspection that happens. For example, they wanted to do it at every quarter and see how things are changing. And to do that, they also wanted to do the data collection in a very easy way, or have it easy. So some of the photos that you saw in the previous slide is the data that was captured by Mike, Damian, and Charles. Charles was in charge of more than, I think, 20 laser scan data that he would capture that day in the field. Mike and Damian captured more than 700 photos, which with ordinary off-the-shelf cameras, so nothing in particular expensive or any special equipment. With that information, first, again, we created the highly detailed 3D model, which you're seeing on the next slide, which the first one that we generated is based on the images. So that's 729 images, which, again, as Mike mentioned, by itself, they're decontextualized. You don't know where you're looking at. What you're seeing here is taking that information, create a highly detailed 3D model of the asset. And now you know exactly, for example, where is that crack map on the asset, or where is that spalling on the asset. And now you know exactly what is wrong on your asset. And then the next thing, as we mentioned, we are able to use different data sources just to create a more complete 3D model. And in this case, we use the laser scan data, mixed that with the images, and we created this 3D model, which upon creating these models, the next step was to go ahead and apply our artificial intelligence technology to detect different damages and see, for example, which damages are in fair condition and which damages are not. So in terms of how we are delivering those to the client and to the asset owner, first we created this, and after creating the models, we create these orthomosaics. The reason we do them is, at the end of the day, the report is in PDF, it's in 2D, so it's needed to have these 2D images, high resolution, that you can copy in your PDFs. What you're seeing here is we are running our AI to detect different damages. In this case, is spalling. So everything that you see there in green color is the spalling that we detected using our artificial intelligence. And more importantly, we are able to quantify those damages. So here you're seeing that we are assigning a number to each of those damages. In this case, it's spalling. And what we provided to the client was two things. One, it was this summary table saying, okay, what is the average, for example, diameter of all the spallings that you have on that side? That's what you're seeing on this slide. Or on top of that, we are providing a detailed Excel sheet that any number which we associate to a spalling, it's the same number regarding the damage ID that you can find in the Excel sheet. And in that, we're providing any different attributes of that spalling, like what is the length of it, what's the width of it, what's the max diameter, what's the surface area for that spalling. And we did the same thing, or replicate the same thing, for all the other damages, like efflorescence, cracks, rust stain, exposed rebar. All of those damages are the ones that we are providing. In another showcase, this time we're working with the capable team of Dennis at Antea Group. This case was a bridge in the Europe. So what we really wanted to showcase here is how powerful is our technology to do this assessment for a larger bridge, and in particular something that we have access issues with it, and how you can actually use this technology to move towards a portfolio level asset management. So what you're seeing here is the first day of data collection. In total, what we wind up collecting with our partners in the Europe was more than 11,000 photos of that very complex asset, which was the double bridge. Again, all of those 11,000 photos, which if you're an engineer, then you have to go through each and every one of them to find damages. Good luck in terms of how much time you have to spend. So what we did was we get that information, created this highly detailed 3D model that not only have all the, captures the overall geometry of the asset, it actually provides details information. So you see like upper portion of the truss and the connections and all of that. And now what you're seeing here is the labeled 3D model. So all those purple colors are showing the corrosions that we wind up finding on that asset. And we are labeling that with a distinctive color. So now you can take that 3D model from wherever you are in the world, render that 3D model on and off all the labels that we provided. So now you know where you have all your damages. In terms of, again, how we calculating the results and quantify, what you're seeing here is the orthomosaic of one of the sides, and in the next slide you're seeing us again run our analysis. On the upper portion you see the binary photo. Every white pixel is showing the corrosion that we wind up finding on that asset, and again we are able to label the model, label the orthomosaic, also provide specific numbering for them, and basically provide the quantification, like how much, for example, how many damages that we have and what's the quantifications of them.
And so, I mean, I know we're tight on time. Oh, how do I stop this? I guess, okay, there. Just to wrap up, right? If I think we enjoyed a lot the doing these projects with you, Dennis, and with you, Michael, and Charles. But if you have some last thoughts in terms of how did you experience these projects, and what do you think are the top of mind for those engineering firms or asset owners that we have in the crowd on like what should these people be thinking about in terms of getting to that goal of using technology across the industry and improving the state of the industry?
Sure, I'll go first since you showed our project first. I think two things really come to mind, not just from the client's perspective, but from our perspective as well too. Number one, it was the ease of data collection. To Ali's point, we had simple Canon cameras, point and shoot cameras, nothing complex, no studio lighting, nothing that a normal bridge inspector would not have in his hands on a daily basis. Yes, we used LiDAR. That did help us give the complete picture, but it was not necessary. So sorry, Charles. But with that being said, it shows how simplistic the process can be. With that all being said, and the last point I want to make is, and it kind of adds with a nice crescendo, we simply could not have done that project without Aren. That is no exaggeration. That is not to help them in their cause today. It is flat out the truth. And that's because a lot of what you saw in that orthomosaic in the video really came into play. When we say there's critical equipment in that structure, I can't get into it. It's literally the lifeblood of one particular island in the Northeast. And should any of that equipment be compromised, severe consequences would occur. As a result of that equipment being there, miles of conduit, ductwork, piping, all interferes. So to be able to go into the room and look straight up at your asset is virtually impossible. To bring in a man lift for any level of conventional inspection is impossible. So what Aren's technology allowed us to do was stand at angles where we could finally view beyond where the ductwork was blocking from directly perpendicular right on under where typically photogrammetry needs you to actually take your images from. We could get to oblique angles. We could zoom in at different focal lengths. We could use 2 different camera platforms and combine all that information to produce the results that you saw that, again, were going to be impossible to yield without having Aren's technology. The client flat out loved it because they saw how complex that the process could have been. They had previous bridge inspection firms come in and say, we simply can't do it. We came to the table that very day and said, we'll get it done. And through Aren's help and Ali and Edgar's due diligence, we were able to do it very, very easily and seamlessly to the point that it was a paid project, and that inspection report has gone on permanent record for that structure.
Dennis, thank you, Mike. Dennis, any last comments?
Yeah, I totally agree with Michael. Also in the Netherlands, everybody's talking about it, and Ali and Edgar, they are not only talking about it; they are proving that it's real technology with real results. And just 2 weeks ago, last week, we talked to the railway government, and they were shocked. They were really shocked. They couldn't believe their eyes what they were seeing, and just asking questions by how can I do more? I have 10 or 15 or 20 critical structures, and would the technique be applicable to those structures as well? So everybody's talking about it, and but Aren is doing it, and learning by doing is the best way to maintain those real critical infrastructure. And I couldn't agree with you more, Michael. Yeah.
Thank you, Dennis. Charles, any last comments?
Thank you, Dennis.
Yeah, I just really want to echo what Mike said. It's just the complexity of the project, and it really attests to your software, really, and what you guys have created. Is it would take so many different input, if you will, from LiDAR to different camera angles to different lighting levels, and really come up with a deliverable for the client that anyone can understand with any background in that environment could understand very, very easily, which is really the I mean, that's what you want to have. So thank you guys again for being part of this project with us.
Well, thank you, Dennis. Thank you, Michael.
Pleasure.
Thank you, Charles. We really appreciate the time. To be honest, like this was a super interesting conversation for us. We hope that also for our audience and for you. And we could go on and on in this topic, but I guess we'll let the next session take place. So thank you very much, everybody, and have a great rest of your evening.
Thank you, guys.
Thank you very much,
everybody. Thank you so much,
Thank
panelists. Really enjoyed the talk. Have a good one, everybody.
Thanks very much, guys.
Bye.
It was a pleasure.
Likewise.